today it will be a busy day, a long day, and we will learn a lot. Our first speaker is Professor Muammer Çalik from Trabzon University, Turkey, and in the program stands that you will speak about effectiveness of socio-scientific issues-based science teaching in promoting scientific literacy. That's good.
Yeah, thank you, Matt. First of all, I'd like to thank you to Professor Vincentas for his kind invitation, because this is the first time I have ever been in Lithuania and met with you. Also, it's a really very good pleasure for me to meet again and introduce with new people also. I will make a speech about effectiveness of socio-scientific issues-based science teaching in promoting scientific literacy. But you know that we have some problems with the Greece and Turkey, and then
I want this.
Don't understand much my
I want it to boycott us.
No war, okay?
Yeah. Let me introduce myself with a few words. I held all my positions from the Karadeniz Technical University. I spent 3 months in University of Waikato and 6 months in Western Michigan University as a postdoc researcher. And I'm also an active editor, reviewer, and editor board member of different well-known journals. Journal of Turkish Science Education, International Journal of Science and Mathematics Education, Education and Science, Canadian Journal of Science, Mathematics and Technology Education. And I'm also an active editorial board member and a reviewer of problems of education in the 21st century, organized and managed by Professor Vincentas Lamanauskas. If you would like to check my studies, you can check my RC and academia and research gauge data, and then you can easily also send an email to me, and then we can contact with each other. In my flow of my presentation, I will first mention about socio-scientific issues, because maybe this is the first time you haven't heard about the socio-scientific issues. I will give some information and definition and key features of socio-scientific issues, and then mention about scientific literacy and its definition and its different versions, and then I will match the relationship between socio-scientific issues and scientific literacy, and finally I will share the findings of our meta-analysis studies published in the International Journal of Science Education to examine effectiveness of socio-scientific issues-based intervention on students' scientific literacy. And then I will share this one. I know that I have a very limited time, and I will try to do my best mathematics. First, I'd like to start with a provocative statement depicted by Linder et al. 2007. It's really a great challenge for science educators and also the current science education. As you will see that science education is not contributing as it could to understanding and addressing such global issues as feeding the world's population, ensuring adequate supplies of water, climate change, and eradication of disease, in which we all have a responsibility to play a role. Students are not made aware of how the solution of any of these will require application of science and technology, along with appropriate and committed social, economic, and political action, as long as their school science is not equipping them to scientifically literate citizens about the issues and the role that science and technology must play. There is little hope that these great issues will be given the political priority and the public support or rejection that they may need. It also shows the importance of science education. As highlighted with the red colors, you will see that two issues were very critical in this quotation. Global issues, sometimes we call it the socio-scientific issues, sometimes name it reasonable disagreement, and controversial issues. But socio-scientific issues term is generally used. And the other thing is also scientifically literate citizens. And first, I will start with the definition of socio-scientific issues, because if we handle any issues as a scientific SSI, this means that we at least have 3 criteria. The first thing is there is no one fixed or universal health point of view. The first criteria. Now, this is like this. 2 plus 2 equal to 4. It's not. It's not a solution. This means that there are some positive and negative issues. Some people support and some people refuse these issues. And divides the society, because different groups may offer conflicting explanation and solutions. And the third one is also a combination of science and society, since they involve interactions among social needs, scientific and technological developments. As you will see the cartoons, look at this: acupuncture, aromatherapy, herbal tea. We could be dealing with a homeopathic killer. Homeopathy as an alternative medical treatment is a socio-scientific issue in those. Medical doctors generally refute alternative medical treatments, but some people still say, yes, alternative medical treatments is very, very useful. And key features of socio-scientific issues include its structured problems or issues, different key beliefs, understanding, values, insufficient evidence, a lack of clear-cut solution, negotiation, a lack of consensus within the scientific community about the issue, open-ended, complex, contentious dilemmas, rational solution derived from the underlying premises, and multiple dimensions. Well, as far as I read about the climate change, some scientists believe that climate change is a fake issue. Some scientists. And some believes that, yes, this is the climate change is the real issue, and then maybe the nightmare of our future. But some scientists say that no. Some people, especially for models climate change, and exaggerate the issues and say that, yes, you should stop CO2 emission. But the other do not believe this one. For the system, we have 2 different ideas and 2 continuous dilemmas about at least climate change. And it also includes dimension of socio-scientific issues, because students need to think about multidimensional, because it includes much more things. For example, economic, religious, ethical, environmental, ecological, health, scientific, technological, societal, and political. For this case, for example, the nuclear power plant, it includes economic dimension, and it also includes environmental, ecological, health, scientific and technological issues, and then also political issues. In your decision making, you should think much more things together, whether you support or refute now the construction of power plant. And the other point is the human cloning. You will see that it includes some health, scientific and technological issues, and sometimes religious and ethical issues. Because some people support that yeah, for infertile couples, because they'd like to have a baby, it's an option for that human cloning for having a baby. But some others say that prompt exploitation and misuse or abuse of this technology. For the system, we have 2 different ideas for socio-scientific issues, and it includes much more dimension. And I will also give some examples about those SSIs and in the related literature. You will see that alternative medical treatment, climate change and global warming is one of them also. And the mostly studied one is also climate change and the global warming one. Mass vaccination, especially for we experienced this during COVID-19 pandemic. Because some people, that rejected to get a shot for vaccination. And organ transportation, overhead power transmission lines, mobile phones, the use of fluoride in municipal water. Now, a few days ago, one of the state, I think Utah state, banned to use of fluoride in the municipal water. because some dentists say that it's useful and protect our teeth. But some others say that no, it's not usable. We always take much more chemicals in our bodies. And in vitro meat, nowadays, we are talking about this one. In vitro meat, they sometimes call it artificial meat. And gene therapy, nuclear power plant, human cloning, tourism in historical places, organic agriculture, biodiversity, dietary supplements, genetically modified organism, abuse of chemical substance, for example, doping, and sometimes carpet for fish pumping, and space pollution. And raw salting, the use of naphthalene in toilet. In a few years ago, we believed that this sodium chloride was an innocent chemical because we can easily get this one. But nowadays, we are talking about its ecological effects, especially for negative effects of the sodium chloride. And the use of naphthalene in toilet tattoo, adding supplementary chemical products into packaged foods, hydroelectric power plant, landfill. Landfill is unfortunately very common in Trabzon because the sea is very close to the mountain and there is no flat place like Šiauliai. For this reason, people generally prefer to landfill the sea and construct some parks and social activity centers, something like that. And the use of chemicals in products that result in environmental pollution, tourism in coral reefs, egg donation, and lab experimental animals, medical use of alcohol, planting biofuel crops by destroying rainforests, and antibiotics, and acid rain and mining. There are some of them. As far as I know, it will be increased day by day because advance in science and technology brings new SSIs for us. For example, nowadays, scientists and science educators discussing about autonomous cars supported by AI. You know that autonomous cars drive themselves, and there is no driver, say, inactively. But some people say that, yeah, if an autonomous car has an accident, what happens? Who is blamed? Who is the responsible? And AI, or owner of AI, or the driver inside? For this reason, we don't have a clear-cut solutions for such issues. And when I checked the effects of SSI-based intervention studies on some variables, I noticed this one because I will explain this also Vision 1, Vision 2, and Vision 3 of scientific literacy. And some of them directly focused on scientific literacy, but some of them focused on argumentation, critical thinking, responsible citizenship, perception of risks, nature of science, reflective judgment, epistemological development, scientific webs of minds, content knowledge or conceptual understanding, decision-making, problem-solving, informal reasoning, interest, attitudes towards SSI, creativity, moral sensitivity, higher-order thinking, scientific thinking skills, so on and so on. And you will see that SSI-based intervention studies examine these variables, whether these are promoted or not. And then they see this one. For example, argumentation is directly related to Vision 2, and critical thinking is related to Vision 2 and 3, and responsible citizenship directly related to Blue and Purple, Vision 3, and then you will see this one. And I explored these variables. And then extracted and inferred some issues of these visions and performance indicators and matched them with each other in our meta-analysis study. In fact, scientific literacy is a very popular term. I'm sure that you know as a science educators because over 50 years we have been discussing about how to improve scientific literacy. But we have not a consensus about the definition of scientific literacy. For this reason, we generally focus on two main questions. to decide its key features or key components. These two main questions is, what can a scientifically literate person do? And the other is, what competences should she have? If we respond to this one, this means that we have some ideas about the key features of scientific literacy or key components of scientific literacy. It also has become a guiding framework in educational policy, and the PISA results, in fact we talked about with Lucas about the PISA results, the cases, and when you will check, it's directly focused on scientific literacy for science education dimension. And a Science for All slogan has prioritized the term scientific literacy for all the world. And we have different, that definition. I would like to share some of definition depicted in the related literature. The first is American Association for the Advancement of Science referred to 4 competencies for scientific literacy. Is aware that science and mathematics and technology are interdependent enterprise with strength and limitation, and understand key concepts and principles of science, is familiar with the natural world and recognize both its diversity and unity, and uses scientific knowledge and scientific ways of thinking for individual and social purposes. It's the definition of AAAS. And another definition comes from the Council of Ministers of Education Canada. And they define scientific literacy an evolving combination of the science-related attitudes, skills, and knowledge students need to develop inquiry, problem-solving, and decision-making abilities to become lifelong learners and to maintain a sense of wonder about the world around them. This is another definition. And according to PISA, a scientifically literate person are able to explain phenomena scientifically and understand scientific inquiry and interpret scientific evidence. This is another definition. Well, in my earlier presentation, I mentioned that there has no consensus about the definition of scientific literacy. And the 21st Century Science Project in England emphasizes 5 components. And the first is appreciating and understanding the impact of science and technology on everyday life, taking informed personal decisions about science-related issues, reading and understanding the essential points of media reports involving scientific matters, reflecting critically on the information, taking part confidently in science-related discussion. And Hudson handled 3 principal elements for scientific literacy. The first is learning science and technology. This is directly related to conceptual understanding and content knowledge. And doing science and technology is related to scientific practices. And learning about science and technology, scientific inquiry. Hudson classified these 3 principles of scientific literacy. And I mentioned in my variables slides that you will see that Vision 1, Vision 2, and Vision 3, it comes from, if I am wrong, but please confirm me that the Sjöström and X. I know X, but Sjöström is the different pronunciation both of army, and reconsidered the 3 visions of scientific literacy and summarized their characteristics. And Vision 1 prioritized comprehending science and its application to solve problems. Vision 2 underscores the usefulness and relevance of scientific knowledge and social dimension of science to make decisions about societal issues in our everyday life. And Vision 3 adopted some key features of Vision 1 and extended its features and called it Vision 3. And added some new dimension and precedes socio-political action and socio-economic justice of science education to educate responsible citizens. That's one the Vision 3. In our meta-analysis, we use this criteria: Vision 1, Vision 2, and Vision 3. And given this diversity of the scope of scientific literacy, Anthony Viersi and me have listed the scientific literacy key features and inferred academic performance indicators in our meta-analysis studies, because we noticed that the variables in the socio-scientific based interventions and the key features of scientific literacy match with each other. They are directly related. And we created these tables you will see here. I will not read the all one. If you want, you can easily download from the journal's websites as a supplementary material. You will see Vision 1, content knowledge or development of scientific understanding or only knowing, theoria. And we inferred conceptual understanding or achievement as an academic performance indicators, given these key features. And for Vision 2, for example, you will see that decision-making or taking informal personal decisions about societal issues or socio-scientific issues or science-related issues. Given these key features, we inferred decision-making process or informal reasoning abilities as an academic performance indicators. And the third one, Vision 3, you will see that problematized relevance for critical citizenship and sustainability or critical sustainability. And given these key features, we inferred critical citizenship for sustainability or critical sustainability or critical rationality or critical thinking. And then we explained in detail about the relation between SSI and scientific literacy, but I will give some high marks for you. First, the use of SSI improves students' engagement, curiosity, and interest in science that stimulates their scientific literacy. And critically handling any SSI within science learning asks students to use their conceptual understanding or knowledge of science concept, because they need to know to interpret the data as SSI. Otherwise, they cannot say anything. Maybe they just only have size bias and explain their negative or positive attributes given her somebody else. But if they have conceptual understanding, and then they can rationally respond to SSIs. And this process calls for Vision 1. And profoundly challenging uncertainty, variety, and complexity of SSIs fosters higher order thinking skills, critical thinking. This is also one of the, the 21st century skills. And it directly serves to 21st century skills also. And engaging students in SSIs help them learn how scientists formulate their hypotheses, develop their methods in regard to their research questions, collect data, and make inference. Such a learning environment obviously promotes their nature of science, scientific habits of minds, and scientific reasoning. This is directly related to Vision 1. And SSI also encourages students to engage in scientific discussion and actively communicate and collaborate with their peers and teachers. As part of Vision 2, these social interactions develop their applied or 21st century skills. For example, collaborative skills, creativity skills, and communication skills. In our meta-analysis, maybe this is the first time some of you that heard about the meta-analysis. Meta-analysis is a secondary analysis, not the primary analysis. For example, I get the data with the sample and conduct some studies, and maybe sometimes pre and post test together. You publish this somewhere else. In meta-analysis, I used your data and give much more information about, and maybe sometimes generalize the findings of the related variables. I'm just doing this one, and this is the secondary analysis. In our meta-analysis, we aim to meta-analytically investigate the effectiveness of SSI-based interventions in promoting students' scientific literacy. And we searched two research questions. To what extent do SSI-based intervention affect students' scientific literacy? How do the moderator variables, educational level, implementation duration, and type of intervention influence students' scientific literacy regarding the interventions? And this shows whether these studies is significant or effective or ineffective. We will give some ideas about the after the results of the meta-analysis. In this process, we will first search some educational databases and search engines. For example, ERIC, Google Scholar, Scopus, British Education Index, Web of Science, Google, and blah blah. You will see that Taylor and Francis, Wiley, and different journals and different publishers' websites using the several keyword patterns. The first pattern is socio-scientific issues, experimental, and science education. We have almost about 12 patterns, and we inserted our keywords in the databases and tried to find related studies. And then, after the applying of our inclusion and exclusion criteria, we had 33 intervention studies. But the studies, one of them is included Eggers et al. Incorporated, two different intervention types. For system meta-analysis, we view it as two individual studies because it's the different intervention. You know that, for example, two experimental groups and one control group. The first experimental group has a different intervention type, and the second experimental group has a different one. And then they have also a control group. And for the system, we think that two individual studies. In meta-analysis, we follow the random effects model because it includes two models: the fixed model and random effects model. Fixed models views that the correct is 1. It's not change. But the random effects believes that it may change in regard to scope, context, samples, and implementation process of studies. For system, we follow the random effects model. Also, we get some, the statistical data from comprehensive meta-analysis software. When we check the Susiję test, it's really very high. This means that, yes, this is heterogeneous. Heterogeneous means that this meta-analysis must follow random effects model. If it's lower, and in that case, we should follow the fixed effects model. But it's really very high for us, and then say that, yeah, it supports our decision, and we follow the random effects model. During the interpretation criteria, you know that we will have some SG or effect size values, and we needed some criteria to interpret them, and we have 6 criteria: negligible, low, medium, large, very large, and perfectly huge. And given these criteria, we also interpreted the effect sizes, especially for the studies effect sizes, for not the common one. And you will see some points. This is the random effects models. This is our overall effect size is 1.018. This means that this fell into the large effect. This shows the effectiveness of SSI-based intervention in promoting scientific literacy. This is just the data. But you will see that some studies show that perfect performance. For example, Lubis et al., you will see 4.071, but some studies did not show any, that good performance. This means that there was no maybe significant difference between the experimental and control groups. You will see Gülce and Sadi, it's a Turkish scholars, and then they say in 0.015, you will see that. This shows different cases for different set values, effect sizes for us, and then we will see that there is a wide range of these studies. And then I will explain the reasons of these issues also. And for the moderator variables, again, when we check the moderator variables, you will see that there was no significant difference between educational levels. And then there was no significant difference, again, type of interventions. But we noticed that there was significant difference between implementation durations. You will see here. And when we check the individual moderator variables, you will see that the best one is high school, because it has the highest effect size. And for implementation duration, medium term is the highest one. In fact, before the intervention, before the meta-analysis, I always thought that, yeah, long term will be very high, but it's not the case. And this also shows that whatever you increase your implementation duration, it's unfortunately getting lower scores. Because it's, maybe sometimes students think it's a regular procedure. For instance, we should enrich our activities. And type of intervention, you will see that problem-based learning is the highest one. Because it's natural, because SSIs always include its structured problems. For instance, problem-based learning seems to have matched with the natural SSIs, and it was the highest scores. In that case, for example, cooperative learning is the lowest one for the type of intervention, and short-term is the lowest one for the implementation duration moderator variable, and middle school has the lowest effect size volumes for the educational levels. In that case, the large effect size of the intervention implies that the SS-based instruction are more effective in improving student scientific literacy than the control ones or comparison ones. And interestingly, the effect size of the SS-based intervention ranged from 0.015 to 4.071. And we noticed that the Lubis studies, when we checked it, what they did, and they had a perfect performance. And when we check that, Lubis had to handle marine ecosystem as a local SSI. And they call it also local wisdom and integrated it into science learning. This means that we always claims that students learn from their close environment and then the remote environment. This shows their attitudes. And whenever they notice that, yeah, my marine ecosystem is very close to us, if something is wrong, this means that it directly affects me. Whenever they think that they shows their much more responsibilities during the science learning, and this results in a perfectly rich effect. And non-significant difference between educational levels and between intervention types mean that they do not significantly moderate scientific literacy along with SS-based interventions. And we also found that the implementation duration significantly moderates students' scientific literacy through the SS-based intervention. Given the categorical difference of the moderator variables, because it's really very important for the science educators and science teachers, we suggested that if you would like to implement SS-based intervention, you can select problem-based learning as a type of intervention. If you'd like to the chance to select a sample, you can focus on high school. And you can also select the medium-term intervention. That will be better. But it may be changed, that it may be dependent on the context of your study. Maybe your national context and other points you should decide this one. For example, as far as my experience in Indonesia, because I participated in several seminars and meetings in Indonesia, and given these studies, some of studies came from Indonesia, and they follow the inquiry-based learning. And whenever we notice that inquiry-based learning somehow is not very useful in Indonesia, because asking question is, that the bad issues for students. Whenever I will be there, and I always said, yeah, you can ask question to me, they always prefer silent. And in that case, it's really very difficult for them to conduct inquiry-based learning in an Indonesian context. For instance, you should decide your national context, maybe the facilities of your schools, and the other points may be national curricula, and then you should decide and select this point. That's a suggestion for that. And this is my last slide, Merga. Yeah, I know that the time is over. We only focused on 3 moderator variables. For instance, we suggest that further research should explore how other variables influence scientific literacy. For example, assessment tool, and then also type of SSI as mentioned to Lubis et al. Studies. We did not make any, that comparison for this one. Local or global SSI. Maybe it may be needed to be explored whether the type of SSI is really moderate their scientific literacy through the interventions. And the given extreme values in the current meta-analysis, for example, you will see that I showed the 2 studies, Gülce and Sadi, and the other Lubis and Edo. Gülce Sadi is the lowest one, and Lubis et al. The highest one. In that case, future studies should qualitatively examine their design and implementation procedures. Also, maybe directly interview with the authors. For example, I'd like to ask the Lubis et al. What did you do in your class and you showed a perfect score? In that case, also I'd like to ask the Gülce and Sadi and said that yes, you conducted an experimental study, but your scores is very the lowest. And what did you do in the class? In some cases, you know that you planned it very well, but something is wrong in the class, and the scores may be very low. And then you should explain it very carefully. This is the future directions of the and implication of the meta-analysis studies. And if you like to read much more information about this meta-analysis, you can check the DD's websites, and then you can also access the International Journal of Science Education. If you would like to read this one, also send an email to me, and then I can share the documents with you. Or maybe you can send a request from ResearchGate or academia, and then I can share the documents with you. And this is the last word, but I'm not sure. Ajukat klausotes. It's correct in Lithuania, but I'm not sure. In Turkish we say that dinlediğiniz için teşekkür ederim. And thanks for your attention. This is my last presentation.
Thank you, Professor Calik. What I remember most was your sentence. They need to know to interpret the data, and then critical thinking follows.
Yeah.
So they must know not only read in AI or
Yes.
only AI knows. But I am sure the questions from the audience will be quite different.
Yeah.
Please.
Yeah. Okay.
Can I start?
Yeah. Of course.
Thank you, Professor, for your nice informative presentation, and you also added another dimension of that variables. Basically, I think more than 3 decades we are also working on various socio-scientific issues in my center. That's the Homi Bhabha Center for Science Education, Mumbai. We really appreciate the issues which you have shared, and the context is very important. Whenever we look at different type of social scientific studies, then we sometimes get influenced. But really we have to look our country context, even sometimes happen on the local context also. Because take example, the construction of road for urban people, the roads are necessary. Transportation, good roads are necessary. But for rural, from where the road goes, that creates a problem for them. The deforestation is there, and then so many social issues are created. My point is that these issues, few issues, when we studied in our longitudinal participatory action research project, I think it's more than 6-7 years with a school student from grade 3 to 9. What we realize that sometimes when we discuss in a different way, because pedagogy is also important issue, how to deal with the socio-scientific issue in a class. Because sometimes, let me tell you, the plastic is a plastic pollution or the wastage of plastic is a problem for other. But those who collected the plastic and their bread and butter is on for them, it's beneficial for them, as you said correctly.
Yeah.
The socio-scientific issue, not necessarily always for one group it's beneficial, for one group it's how to deal that things. That is another my problem, which I would like to your opinion on that. How to deal such issues, and then what sort of pedagogy one can use for inclusive participation in a classroom, basically. These are my questions. Thank you.
Okay, thank you.
Once again. Is it clear to you?
It's clear for me. Thanks for your question. For example, the context is really very important. In my postdoc positions in Western Michigan University, I visited Michigan in the winter season. The weather was very cold, and I decided to use road salting as a SSI because it's very common in this case. They easily use and throw sodium chloride somewhere else, and it's really easy for them. And I decided that the road salting is important. But in my cases in SSIs, I generally prefer to conduct some hands-on and minds-on activities before the SSI, because they need to learn some conceptual understanding and related science concepts first. For example, in the road salting cases, I taught them, that phrasing point interpretation, and then also the solubility factors affecting their solubility, and that they have some activities, and then I spread out some, some worksheet and some things like that. Yeah, could you interpret this SSI and maybe checkpoints of whether you support or dissupport, these issues. And then I used this one in this case. But the first thing, especially for hands-on hands-on activities. Also, I will share the papers because I have published one in chemistry education, research and practice. And we use the common knowledge construction model supposed by Jazzy Nabenezer, and then we use it. And if you want, I can share this document with you because it's used. The first starts with categorization and exploration, and classification and negotiation, and then the other points is also includes the third points is socio-scientific and societal issues in the third phase, and then the evaluation. If you like the one, I would like to share the documents with you, how to integrate SSI in especially for science learning and science classes. I hope it's clear.
Yeah.
Thank you.
The lady first.
Yeah.
I'm sorry.
Yes, thank you for your presentation. You mentioned the PISA definition about scientific literacy. Nowadays, for researchers in 25 years, PISA used the new term, scientific identity. What is your opinion about this term?
Yeah, it is always related to the scientific literacy. That sometimes terms are changed, but it is scopes is almost overlap some nuanced issues difference, and then they prefer this one.
Because you used the social aspect of
Yes. Yeah.
And now, Professor?
Oh, possibly last question. Just methodological, you mentioned duration, intervention duration. I mean long-term, short-term, and medium-term. But in what scale? Because it's...
Yeah. I forgot, in fact, I mentioned it in the paper, but I forgot to do this one. Short-term includes about 1 to 4 weeks. And medium-term includes 5 to 8 weeks. And the long term is 9 weeks and above. That's just one. And this means that 9 weeks, maybe 10 weeks, that takes about maybe, about 3 months about these activities. And if you frequently use SSI in your science classes, and this means that their interest and their performances is lower than over time. This shows the case, that's one.
Angela?
Yeah. So in listening to you, you know, one of the aspects that we work with our first year students, so we've designed a particular program that's called Toolbox. So it has all the basic types of understandings, concepts, the use of a microscope, etc., etc. Because our students have come from secondary schools where they have not had those types of experiences. So I work with the science literacy aspect, and within that, we looked at common diseases within Africa and South Africa. And then we said, okay, with these students, now let's look at an SSI investigation. Can you go into your own communities and establish just amongst your family, you know, not the clinics or whatever, just what are the common diseases? And then how can we then document that and then share that? But now, more than that, how can we then create a poster where we have information and we can put that in a public space in the language of the people? So a colleague said to me, I don't think what you're doing relates to what we want to do, because the students are not learning the concepts, they're not learning the content. And I'm saying, we're moving beyond the content, because they need to understand the content in order for them to be able to do that. So for me, it's SSI is important for science literacies, but that's not how everybody views it.
Yes.
So what is your take on it?
How
does one raise the argument further?
I think so. You know that, and sometimes you do not need to. Maybe you don't have any other lab experiments and encourage learning and something like that. But maybe this is the dimension of scientific literacy. You know that they should read maybe news, media, and other points and interpret the data and to collect data from social media or something like that. If this is the case. In that case, they should also learn conceptually concepts and content and understanding. It's really very critical point. As far as my experience, because I have also been teaching SS-based instruction in my faculties for postgraduate degrees, and it's really very good performances. Even if primary school teachers, I have been, and I know also primary school students. When one of my students just completed her master thesis, and we directly focused on the comparison between, you know, that grade 2 to 4. They are really very young, 8 years old to 9, 10 years old. Their arguments are very, very, very good for the cases. But we selected the local SSI because they should learn and something from the different points. They did not get any data from the direct lab experiments and something like that. They just learn, ask their parents, ask their families, and read the papers and some, the documents, and then they produce their arguments. And then they provide us very good evidence that, yes, I read these news that blah, 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 something like that. It's really very important for the use of and the applicability of SS-based information. I think that. Angela, thank you for your question.
So, Professor Calik, we expected no less than learning a lot of you. And thank you.
Thank you so much.
Thank you so much.
Thank you so much.